Hello, I'm here to show how to make a data-oriented first-person player controller in Unity. Now we start off with an obvious question in mind. Why make it data-oriented? Or even, what is data-oriented programming? In short, data-oriented programming relies on reading and storing data that is separated from the code. This is unlike object-oriented programming that relies on instances of objects and behaviors that define data. You are primarily handling primitive data like floats or int arrays that are saved in a file. Unity scriptable objects can be used to store data in this fashion. When I first learned how to create a player controller, I was taught the object oriented way by creating a hierarchical state machine. You make a class for every state and a state machine that instantiates and handles these state objects. States tend to have very similar logic, so you create an inheritance tree. Every state where the player is on the ground can inherit from ground state, and every state where the player is in the air can inherit from airborne state. All these states read the player's move inputs, so airborne state and ground state can inherit from movement state, and so on and so on. I was sold on the OOP way of life. As the development went on, the player controller started to feel difficult to work with. I had these different instances of states and didn't know how I should connect them all. Wall combat states. How do I structure all of this? Being in wall state isn't technically airborne because the Y velocity is zero, but it's not ground either because, well, the player isn't on the ground. Okay, well, let's make a new wall state that inherits from movement state and branch from there. From wall state, I have hang state and climb state. Easy. Ah, but now I want a wall jump. What state does that inherit from? I need some properties from both the airborne and wall parent classes. Now I want some combat states. I got a few types of those. I got ground punch, jump kick, wall shoot, jump shoot. These should all be connected somehow, but they are also connected to all the other parent states. Now I need a death state. The player should be able to die from any state, so this branch stems from the top of the tree. That's a completely new branch. And what about landing? Where I need Y velocity from the airborne state so I can tell whether or not the player will take fall damage. This isn't gameplay programming. All my focus was on this gigantic state tree structure that seemed so maintainable in the beginning. What I found was that hierarchical state machine structures attempt to cast a broad net for every gameplay situation and feature, limiting as much unique lines of code as possible. But I found this was bad. The backend code became very generic and the front end was full of indirection and obfuscation. When I wanted to add in a simple feature, like another combat state, I could no longer just code that in. I had to follow the chain, call certain override functions, and inherit from certain classes that theoretically should make this process cleaner. These inheriting classes force me to write code that often don't help with the front end logic and cause speed bumps along the way. Debugging at this scale is also a difficult task. Maybe I found a bug where a float value is not what it's supposed to be, so now I get to follow the chain of this variable. The bug could be in any one of these classes that have reference to this float. The further up the chain, the more of the process I have to remember and understand. Now I have 15 or so script files open in Visual Studio and end up being lost to something that should be so simple to track. These hierarchical state machines aren't what they're sold to be. Now, maybe I made some mistakes. I didn't plan the code base properly. But every hierarchical state machine I make ends this way. I just hoped that I could push through to finish the game. So, let's go over a few critical issues. There's too many scripts, too much constraint, overcomplicated structure to add simple features, and an overcomplicated process to debug. We'll come back to this list later. A data oriented player controller offers a different approach. Instead of an instance of a class for each state, it's just an enum. That's it. Now, instead of every state class handling its own logic, it's a switch case statement. Instead of being in 3 or 4 different states at once, the player is just in one. This is usually how beginner state machines are taught, but us as programmers tend to want the biggest scale state machine structure and find ways to limit all the typing because that will be the most productive. So we usually jump to that without even thinking and questioning what a scaled up switch case state machine may look like. On my player controller, I start by writing an enum where I can define each state type and then hold a reference of the current state of the player. Next, I have the choose_state method that is called an update. This is where I will define all the logic which will end up being a big if-else statement. I used to think this was an amateur coding practice. However, being a simple if-else statement made it more manageable as it keeps all the logic in one function and in one class. I'll leave it empty for now. The next method is the set state, where I will change the current state of the player based on the new state input. Again, I will leave this method empty. I have enter state, which is called on the first frame of the state change, update state that is called every frame, and fixed update state, which is called on every fixed frame. Last is exit state, the last frame before the current state changes. I will call update state and fixed update state in their respective monobehavior methods. Set state is called in the choose state method within each if else statement. To start with a simple example, I will define a vector3 variable that will define the player's movement inputs. Normally, this data is stored in a scriptable object and handled in an input manager, but for the purposes of this tutorial, having it as a private variable is fine. In choose state, we can write a simple if else statement like this, where if there is no player input, I will set the current state to idle, and if there is input, I will set it to walk. Like I said before, the more states, the larger and more specific this if else statement will be. For a more scaled example, this is my choose state method in one of my prototypes. As you build, this if else statement naturally creates a priority. At runtime, the method will go down the chain until one of them is true at that given frame, ensuring exactly one state is set each frame. Now on to set state. The first line is a guard statement. If the current state is the same as the new state, don't do anything. This will ensure that changing states will only occur for a single frame. On the line below, we simply change to the new state because now we know that the current state and the new state are different. If you can imagine the next frame, the current state will have updated, and unless we have changed states again, the method will return early. We can take advantage of these single frame calls for enter state and exit state. Exit state will be called in between these two lines. At this line, we know the current state is about to change, so before we do that, we can call the exit method. Enter state is called after the current state has changed, again knowing that this will be the first frame of the new state. So now the state machine structure is done. We can write up logic directly into each state with a switch case statement. This will be in all four methods. You don't have to write every state for every method, but the offer is always there, which I find to be quite flexible when adding and removing new states. I might do a physics tutorial later on, but for now I'll just get the player to move linearly with some debug logs to show the enter and exit methods are working sufficiently. And that is the core structure. Granted, these are the first steps to creating this state machine, and will have to be put to the test, which I plan to show later on. But there are already some things consolidated here that will remain consistent throughout the development. This is one script. The code should be transparent and direct. Yes, there may be more typing, but that's a bottleneck easily handled. Just type faster, I guess. The rules here are loose. I'm not giving myself abstract functions or interfaces that I must use for every state. The switch case statements just offer me a moment in time of gameplay where I can add whatever logic I want. Speaking of adding logic, that's all I should be doing. If I want to add a new state, I just add to the state enum and write the code in the designated case of whichever the four methods. That's it. It's not creating a class that must inherit from some other abstract class that holds all the generic methods and variables. The state tree is one level deep, so variables are easy to track. I'll expand on that part more as well when I start to use scriptable objects so other game objects can read these values independently from the player's game object. Just to clarify, I don't think OOP is bad. For me at least, this workflow just solves a lot of issues that mattered to me, and now I find myself more productive. This doesn't mean I think data oriented programming is the answer for everything, too. There's always a balance. In fact, my state machine inherits from monobehavior and is written in C Sharp, an OOP language. OOP state machines are definitely valid too, and it's probably worth learning them anyways. Where I find programming to be fun is when I learn a variety of methods and I get to pick and choose what I think would be the best workflow for the given use case. But anyways, that's my video. Thank you for listening.